Alright, so if there's an odd number of rope segments coming into one umbrella, that umbrella must be an endpoint.
If you have an odd number, then that means that you have to have the end of the rope.
Oh!
Got that not by thinking about the endpoints, but by thinking about one rope comes in and goes out, then that makes 2 extra segments. If it's not an endpoint, it has to be 2 extra segments. So, with the umbrellas, we couldn't have more than 2 umbrellas with odd ends. So what does this have to do with the bridges of Konigsberg? Somehow or other, it looks pretty similar, right? And if you imagine that we put a monster in each of the 4 districts, and they had their umbrella up, that would look a little bit like a little rope segment going over this path, a little rope segment coming back on that path, a little rope segment going across that path, right? So the districts are like the umbrellas and the monsters, and the rope segments between the umbrellas and monsters are like the bridges. And then the one big rope that would cover the whole thing is like the path that walks over all of the bridges. But in this case, we've got 4 different districts, so that's like 4 monsters with umbrellas, and each monster has an odd number of bridges. There's like 3, 5, 3, 3. Well, that's no good. That's 4 odd rope segments. So it can't work. There's 4 districts. Each district has to be either the start or the end of the path. But that's not going to work, because you can only have 1 start and 1 end. So there's only 2 districts can be starts or ends, but we've got 4. It doesn't work. There's no way we can do it. We've solved the bridges of Konigsberg. It would be the same if there were 4 umbrellas and 4 monsters, and the rope segments looked like just like the bridges of Konigsberg. Wait, that's 4 umbrellas. That's rope segments that correspond exactly to the Konigsberg. So the red one's holding an end. Everybody's convinced the red one's holding an end. We've got red and orange over here.
Wait, they all have an odd number.
Everybody has to be holding an end.
Wait, there's more than 1 rope. That's why I think it's a rope.
We have a new theory. Somebody's thinking outside the box here. So this is a situation that we couldn't possibly do with 1 rope, right? It's scary sometimes when it looks like our reasoning might have taken us astray. But you know what? That happens to the best of mathematical explorers. The best mathematicians in the world sometimes get caught up like that. And it's very comforting when you realize that actually your arguments hold. All right, let's turn to another place where parity helps. Parity meaning the oddness of things. Let's suppose you have a chessboard and you want to cover it with dominoes. Seems reasonable. Could just put 2, 4, 6, 8, 4 across the top one, 4 on each row, and it'd be fine. But what if I took out that top left corner? Could we do it? There's a simple argument that says you can't. How many squares does each domino take up? 2! But if we've taken out 1 corner, how many squares have we got left? 63! And 63 is odd. And if we're only taking 2 away at each time, it doesn't matter where we put them. There's no way we could possibly take 63 off. Alright, what if I remove 2 corners diagonally opposite? That argument's not going to stop us anymore, because there's 62 squares left.
And you can do it 62.
All right, so let's have a go. See if you can cover the chessboard with dominoes. This next interactive lets you have a try.